Good morning and welcome back to Environmental Science. Here's just a little video review of the PowerPoint that was posted before we left. The atmosphere is mostly comprised of nitrogen, oxygen, argon, and carbon dioxide. These four main components make up the majority of our atmosphere. They also provide us a service, generally known as an ecosystem service. This blocks UV radiation, moderates the climate, and redistributes water in the hydrologic cycle. There are four main layers of the atmosphere. The troposphere, which is where we actually live, and it contains our weather. Then the stratosphere. This is where commercial jets fly. It contains a layer of ozone that absorbs much of the sun's damaging ultraviolet radiation. Temperatures increase with increasing altitude here, because the absorption of UV radiation heats up the air. Next, you have the mesosphere, which extends to approximately 50 miles above the Earth. It is directly above the stratosphere, and here temperatures drop to the lowest in the atmosphere. Lastly, you have the thermosphere. Gases are extremely thin. They absorb X-rays and shortwave radiation, and the temperature of each individual molecule is nearly 1,000 degrees centigrade. But remember, there are very few molecules here, so it would be very cold. Atmospheric circulation is where air circulates in the atmosphere. So you'll see that the sun causes the ground to be warmed up. This warm air will rise. As it rises, it cools and then begins to sink back. Here's what bad air pollution may look like. Some terms that you need to be familiar with are ppms, parts per million, ppmv, parts per million by volume. So if you take a liter of gas, how many parts per million would you have in that liter of gas? ppbs are parts per billion. And then concentration, which is in moles per liter. What is air pollution? So the definition of air pollution is any addition of harmful substances to the atmosphere, resulting in damage to the environment, human health, and quality of life. It can occur indoor or outdoor. It could be in cities or across continents or even global. Air pollutants consist of gases, odors, suspended particles like dust, fumes, mist, and smoke. Some types of air pollution. We have particulate matter, and you measure particulate matter in the size it is. So you have particulate matter that is 2.5 microns and particulate matter that is 10 microns. There's also lead and ozone. We think normally of ozone as something that is good, but when it is in smog, it is actually a very bad thing to be breathing in. Particulate matter has a number of effects. It scatters and absorbs sunlight. Trace amounts can bind to particulates, and the effects are less sunlight gets in, and then the smaller the particle is, the more harmful the effects are. Some other types of air pollution are oxides of nitrogen. You get NOxes, sulfur dioxide, which actually turn into SOxes, and carbon monoxide. Here we have a little diagram depicting smog and how smog forms. But basically you have a source of pollutants like a car, factories, and these go into the atmosphere and react with water or oxygen and sunlight, and they will actually become nitric acid, peroxyl nitrates, formaldehydes or other aldehydes, and ozone. So what actually causes this pollution? Well, some of it is by attrition, the wearing or grinding of a substance by friction. This creates particles called particulates, or fine droplets called aerosols. Vaporization is the process in which liquid changes to gas, and then you have combustion, or the burning of something. We have mobile sources of pollution, such as cars, trucks, tractors, and heavy construction equipment. We also have stationary sources, like power plants, factories, and than burning forests. So how does air pollution actually affect people? Well, it contributes to asthma, emphysema, it can cause death, and cancer. The populations that are most at risk from air pollution are the elderly, the very young, outdoor exercises, and people with existing respiratory problems. So as we think about this, all places in the world are not equal when we consider air pollution. We have cities that produce more pollution and actually feel the effects more greatly. However, this pollution can spread when wind comes and actually push it down into more rural communities that are not normally affected by air pollution. So, what have we done to fix this? Well, in the 1970s, the Congress passed the Clean Air Act, where the Environmental Protection Agency established national ambient air quality standards. This set maximum amounts of specific pollutants allowed in the outside air. Criteria pollutants are any pollutants that have health effects. The Clean Air Act forces the EPA to actually oversee air pollution. Some of the things that they regulate are carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, lead, particulate matter of 10 microns, particulate matter of 2.5 microns. The sources that are regulated, if they have a potential to emit over 100 tons of any regulated pollutant. Now remember, ozone is not something that's directly emitted. It is a secondary pollutant, which means it forms in the atmosphere from other molecules. The Clean Air Act also established the national emission standards for hazardous air pollutants. It also regulates carcinogens, mutagens, and then reproductive toxins, and the current list has about 188 pollutants. An Air Quality Index, or the AQI, is pretty easy to understand. If you have an AQI of 100, then the concentration of pollutants is equal to the national air quality standards. If it's over 100, then the concentration exceeds the standards. So here we just have the scale. So if we have green air quality, you have an AQI between 0 and 50. Moderate, 50 to 100. Remember, this is considered good. Then you have anything above that, which gets you to the orange, red, purple, and maroon levels. You may have heard about red air quality in Denver.